Hello everyone. So kule video sizothoma isection ye-calculus, and then later we will move on to cubic functions, right? So as an introduction, I want us to go through the nodes of calculus and then do some examples as we go, right? So in this way, I will just go through the notes. Uzama ukungifollowa ukuthi maybe ngichaza ngithini, right? So this section in calculus, it starts off by talking about the average gradient. I'm sure by now we all know what the gradient is or how to calculate the gradient. We know what the gradient is the change in the x values divided by the change in the y value. It's the change in the y values divided by the change in the x values, right? So that's why we have y2 minus y1 over x2 minus x1, right? And then Lago activity 1, they're just calculating a gradient, which we all know by now. To determine the gradient of the graph between 2 points, we know what we get the first coordinate yaga y, subtract the second one divided by the first coordinate yaga x divided by the second one, right? So all that they're doing here is just calculating the gradient, which we all know, right? And then what we are more interested in is how this relates to a calculus or a gradient of a curve. So in the Bayenza calculus, they are sort of like trying to calculate a gradient of a curve. By now we know how to calculate the gradient of a straight line, right? We know what we just take 2 points and connect a line through those points, and then we can calculate the gradient. But then how will you calculate the gradient of a curve, right? Like they have here, it's sort of like an exponential graph. How will you calculate the gradient of a curve, right? So that is sort of like the whole aim of calculus. We trying to calculate the gradient of a curve, right? Lanabati, the average gradient between 2 points on a curve is equals to the gradient of the straight line through the points. So the average gradient between point A and B is the gradient of the line AB, right? So if you want to calculate the average gradient of a curve, you'll just pick 2 points on that curve and then sort of like connect a straight line to those points and then calculate the gradient of that line, right? That will give you the average gradient of that curve, the average gradient between 2 points on that curve, right? So as 2 points move closer together, the average gradient approaches the gradient of a curve, which is also the gradient of the tangent to the curve at that point. So the gradient of the curve at AB is 80, right? So now when you start off with AB and calculate the gradient, you'll use these 2 points A and B, right? But then as you move, let's say point A closer to point B, as you move point A closer to point B, your average gradient between those 2 points will also change, right? And the closer the points become, the more the gradient will be more or less the same to the gradient of the tangent connecting the tangent to a point. Okay, let us sort of like try to discuss this through a sketch. Okay, so let us say maybe we have a curve. Maybe let's say we have a parabola, right? We have a standard parabola, y equals to x squared. Now we have 2 points A and B, right? We have 2 points A and B, And then when you go through the notes, but the average gradient between 2 points on a curve is equal to the gradient of the line through the points, right? So now if you want to calculate the average gradient of this part of the curve, you will estimate that gradient by calculating the gradient of a line, a straight line, crossing those 2 points, right? So if you calculate the gradient of this line, you will get an estimate of the gradient of the curve between those 2 points. I don't know if that makes sense, but then yeah, that's what it is. It will make more sense if we do examples. Okay, so now as you move the points, the 2 points closer together, the average gradient approaches the gradient of the curve, right, which is also the gradient of the tangent to the curve at that point, right? As you move these points closer and closer together, you see your average gradient will almost be the exact gradient of the curve, right? Because we are estimating the gradient of the curve by using the gradient of straight lines crossing 2 points on the curve. Okay, and then the closer you move the points up until maybe let's say point A is now moved closer to point B, you'll have your gradient at this point on the curve to be the same as the gradient of the tangent that passes through the point. I don't know how to explain this, but then the way to calculate the gradient of a curve, you are using straight lines as approximations like of the actual gradient, and then when you want to calculate the gradient at a specific point on a curve, that gradient will be the same as the tangent passing through that point. That gradient will be the same as the gradient of the tangent passing through that point, right? So the gradient of this curve at point A is the same as the gradient of the tangent passing through point A, right? And the gradient of this curve at point B is the same as the gradient of the tangent passing through point B, right? Yeah, into ebazama ukuyichaza ngileyo, right? Also remember that the tangent is a line that touches a curve at one point only. The average gradient tells us whether the graph is increasing or decreasing between those 2 points, right? So if your gradient is positive, we know what your function is increasing between those 2 points, and if it's negative, we know what your function is decreasing between those 2 points, right? So okay, by actual decreasing it's negative gradient, increasing it's positive gradient. And then they also talk about the average rate of change. The average rate of change is maybe just a fancy way of calling a gradient, right? But then here, instead of dividing by x values, you sort of divide by the time, right? So the rate of change of something is you are calculating the change of something divided by the change in time, right? Like for example, the average speed is calculated as the rate of change in distance, right? We're saying the rate of change in distance because we are calculating the change in distance over the change in time. So in terms of x and y, the gradient can be interpreted as the change in x over the change in y over change in x, right? So the average gradient, the average rate of change between 2 points on a graph is the average gradient of the line joining those 2 points. Okay, so if the graph shows the distance as a function of time, the average gradient will be the change in distance over change in time, which is just the rate of change, right? whenever you hear the term rate of change, whenever you hear rate, it has to do with time, right? And then rate of change, we are dividing the change in something over the change in time, right? I'm sure you've come across this physics at some point. And then now we move on to the derivative of a function at a point, right? Here they're saying the rate of change of a function at a point is called a derivative. So a gradient at a point is sort of like a derivative. The derivative of a function at a point gives the rate of change of the function at that point. So the derivative of the function at this point is the gradient of the function at this point. That's all they are trying to say. The derivative of the function at this point is the gradient of the function at that point, which is the gradient, which is the same as the gradient of the tangent passing through that point, right? So yeah, that's why the rate of change, rate of change is just another fancy way of calling a gradient. So the rate of change of a function at a point is called a derivative, right? Or you can say the gradient of a function at a point is called a derivative. So the derivative of a function at a point gives the rate of change of a function at that point. The slope or the gradient of the tangent to that point will be the same. Okay, let me put it this way: the gradient of a function at a point will be the same as the gradient of the tangent passing through that point. I think saying it casually already. And then here, this is the notation for f derivative, right? F prime x is the rate of change of f at x, right? So we will use the derivatives to calculate function the gradient of a curve or of a function, right? So now here we have the definition of a derivative. They say the derivative of a function y equals to f of x is defined as f prime x equals to the limit as h goes to 0 of f of x plus h minus f of x divided by h, right? This is just another way of describing the gradient, right? So to have an example and sort of a visualization of how to interpret the definition of a limit, let's say we have a graph f of x is equals to x squared, which is the standard parabola, and then let's say we want to calculate, okay, so f prime x is just us wanting to calculate the gradient of the function at a point x, right? So let us have our point x here, right? And then this point here will be f of x. The coordinate of that point will be x f of x, x f of x, right? The coordinates of point, let's call it point A. The coordinates of point A, right? These are the coordinates of point A. So we are interested in calculating the gradient of the curve at this point. So to do that, we pick another point x plus h. We pick another point x plus h. Let us call it point B, right? So that will be f of x plus h. Let us call that point B. The coordinates of point B will be x plus h, f of x plus h, right? Our interest is to calculate the gradient of the function at this point A, right? Which is why we have f prime x there, right? Our point of interest is that x. So to calculate the gradient of this point, we need another point which we can use to have an estimate of the gradient, right? So we know to calculate the gradient of the curve between these 2 points, we'll just connect a straight line between points A and B and use the average gradient of that line as the gradient of the curve between these 2 points. But then now we are interested in the gradient of this curve at a specific point A. So to have an estimate of this gradient, we will have to move this point closer to that point. We have to move point B closer to point A. The way to do that, we have to make h be as small as possible, which is why here we are saying the limit as h goes to 0, right? When you make h small enough, you will have a better estimate of the gradient of the curve at this point A, right? Which will be the gradient of the tangent passing through that point, right? I know it might be confusing, or maybe it sounds too complicated, but then this is just a way of describing the gradient of a curve at a specific point, right? So now we know what the f prime x is defined as f of x plus h minus f of x divided by h, right? So now if you think about it, the way to calculate the gradient between A and B, you'll say, let's say the gradient between A and B is equals to y2 minus y1 over x2 minus x1, right? And then let us pick the point B as our x1 and y1, as our x2 and y2, and then it is as our x1 and y1, right? So now the way to calculate the gradient, will say it will be f of x, it's y2, which is f of x plus h, minus y1, which is f of x, divided by x2, which is x plus h, minus x1, which is x. So this will become f of x plus h minus f of x divided by x minus x will just remain with h. So yabona ukuthi la kule definition they are just calculating the gradient of a curve at a specific point, that point being x, right? So if you say f prime 2, it means you want to calculate the gradient of the function, of this function, at a certain point where the x coordinate is 2, right? Okay, I hope it makes sense. If not, hopefully when we're doing examples it will start being clear, right? So that is the definition of a derivative of a function at a point x, right? So yeah, this formula is provided in your formula sheet in the final exam. The notation we use for the derivative of y equals to f of x is f prime x or y prime or dy dx or dx f of x, right? We find the derivative of a function. When we're finding the derivative of a function, we say we differentiate the function. Okay, so from first principles, this is how we differentiate. We'll do that using an example. We differentiate by using the definition of a derivative, right? So this is another way of like getting free marks if they say derive from first principle or differentiate from first principles, right? So now let us do this example. We have a function f of x equals to minus 3, and then we want to determine the derivative of f at x from first principles, right? We have our function f of x is equals to minus 3x squared, right? We want to derive from first principles, right? I know my definition of the derivative is f of x equals to the limit as h goes to 0 of f of x plus h minus f of x divided by h. Ne? So to begin solving this question, I will need to calculate f of x plus h minus f of x, right? So the numerator, we need to calculate f of x plus h. F of x plus h will be equals to minus 3. Wherever I see x in my function, I put x plus h squared minus 3. Now I expand the brackets, x plus h, and then I just expand again. I'll have x times x is x squared, x times h is xh, x times h is xh again, h times h is h squared, right? And then I have minus 3 x squared minus, I'll have 2xh, right? Minus 3 times the 2xh will be minus 6xh, right? And then minus 3h squared, right? So, and then now I need to calculate my numerator, which is f of x plus h minus f of x, right? I already have f of x plus h, which is minus 3x squared minus 6xh minus 3h squared, and then f of x is just my function, so it will be minus 3x squared, so it will be plus 3x squared, right? So this and that will cancel. I'll be left with minus 6xh minus 3h squared, right? And then now I can substitute this into my numerator. So I'll have f of f prime x is equal to the limit as h goes to 0 of minus 6xh minus 3h squared divided by h. So now I can factor h out from my numerator. I'll have the limit as h goes to 0 of h minus 6x minus 3h squared divided by h. That h and that h will cancel. Now I'll have the limit as h goes to 0 of minus 6x minus 3h squared. So wherever I see h, now I can put 0 and I'll have my answer, right? So my final answer, if I put 0 where I see h there, will be minus 6x. Okay, so differentiating from first principles, it's easy marks. Usually it goes for 5 marks or 4, right? So this is an easy way of getting marks. Okay, so yeah, let us look at another example, activity 2. Activity 2, okay, so let us copy activity 2 to our whiteboard. Okay, so they want us to determine the derivative of f from first principles, right? Our function is f of x equals to 5x squared minus 4x plus 2. So we know the definition of the derivative is the limit as h goes to 0 of f of x plus h minus f of x divided by h, right? Now first things first, I need to calculate f of x plus h. Okay? Wherever I see x in my function, I put f of x, I put x plus h. So I'll have 5 times x plus h squared minus 4 times x plus h plus 2, right? And then now I simplify. Here I'll have 5 times x squared plus 2xh plus h squared minus 4x minus 4h plus 2, okay? And then I'll have 5x squared plus 5x squared plus 10xh plus 5h squared minus 4x minus 4h plus 2, right? And then now I need to calculate my numerator, which is f of x plus h minus f of x, which is equals to 5x squared. F of x plus h is this whole expression, is 5x squared plus 10xh plus 5h squared minus 4x minus 4h plus 2 minus my function now f of x, which is going to be minus 5x squared plus 4x minus 2, right? So this minus 2 and that 2 will cancel. This 4x and that minus 4x will cancel. This minus 5x squared and that 5x squared will cancel. And then I will be left with 10xh plus 5h squared minus 4h, right? So this will be my numerator. So if now I divide this whole thing by h, I'll have f of x plus h minus f of x divided by h is equals to 10x. I'll factorize my numerator, 10x plus 5h minus 4 divided by h. So I will have 10x, this and that will cancel. I'll have 10x plus 5h minus 4. Okay, so now I can proceed to calculating the limit. So my f derivative will be the limit as h goes to 0 of f of x plus h minus f of x divided by h, which is this expression, right? So it will be 10x plus 5h minus 4, right? Wherever I see h now, I just put 0. So my final answer will be 10x minus 4. Okay, an easy 6 marks. And then we go on to question 2. Okay, question 2. We calculate the derivative from first principles of f of x equals to 2 over x plus h, right? We know from the definition of the derivative is the limit as h goes to 0 of f of x plus h minus f of x divided by h. First things first, I need to calculate f of x plus h, right? And then wherever I see x in my function, I just put f of x plus h. I just put x plus h, right? So there I'll have 2 over x plus h, right? And then the next part is to calculate my numerator, which is f of x plus h, minus f of x, which will be 2 over x plus h minus 2 over x, right? And then now we need to find a common denominator. To do that, we'll multiply this by x over x and this by x plus h over x plus h. So we'll have 2 over x plus h multiplied by x over x and then minus 2 over x, right, multiplied by x plus h over x plus h, right? That is a way of finding the common denominator. So here we'll have 2x minus 2x plus h divided by x times x plus h, right? So here we'll have 2x minus 2x minus 2h divided by x plus h, which will be that, and that will cancel, which will be minus 2h divided by x times x plus h. Okay, and then now we can divide this by h. We have f of x plus h minus f of x divided by h, right? So we'll have our numerator divided by h, so we'll have minus 2h x times x plus h all divided by h. So this will be equals to minus 2h over xh. Okay, it will be minus 2h over x times x plus h times 1 over h, right? This h and that h will cancel. We will be left with minus 2 over x times x plus h. So now we can go ahead and calculate our limit. So we'll have our f prime x to be the limit as h goes to 0 of minus 2 over x times x plus h. And then now at this stage, wherever we see h, we just put 0 to have our final answer of minus 2 over x times x, which is just minus 2 over x squared, right? Okay, I think we'll just stop here for this video, and then we'll proceed to using the rules of differentiation in the next videos. Okay.